Imagine a world where software could patch its own vulnerabilities, fix its own mistakes. Sounds like, I don't know, science fiction, right?
It really does, yeah. It conjures up that kind of image. And yet, that's the incredibly innovative space we're digging into today.
Exactly. So today, we're doing a deep dive into the creation of AI agents. These are specifically designed to automate those really crucial, but let's be honest, often time-draining tasks.
So like fixing bugs and reviewing code.
Precisely.
Yeah, these are just fundamental activities in software development, aren't they? And the potential to streamline them is, well, it's pretty significant.
Absolutely. And that really gets to the heart of the problem, doesn't it? Just the sheer amount of human effort that currently goes into keeping software running smoothly.
And the constant push to improve code quality, but without slowing everything down.
Right. So to give everyone a tangible look at how this is actually unfolding, we've been looking into the principles behind a really fascinating system built with Python.
That's right. This system uses large language models, LLMs, and these autonomous agents to tackle these exact challenges head on.
So we're going to break down its core ambitions, how it actually works, the mechanics of it, and, the bigger implications for the tech world.
Okay, so by the end of our chat, you'll hopefully have a good grasp on how AI is being used to create more resilient, sort of self-managing software.
And what that might mean for the future of building and maintaining software.
Exactly.
Okay, so let's jump right in. The basic goal here, it seems, is really about cutting down the manual effort needed for, the day-to-day upkeep of software.
That's precisely the driving force. I mean, think about the sheer volume of issues that can pile up on a platform like GitHub.
Oh, yeah.
The idea is for the system to intelligently handle a big chunk of that workload automatically.
Right.
This gets us closer to, a truly adaptive software ecosystem where that maintenance burden hopefully shrinks over time.
Freeing up resources, developer time.
Exactly. Freeing up people from just keeping the lights on, so to speak.
Yeah. Okay. So what are the key objectives then? How does this big aim become a reality?
Well, first off, accelerating bug fixes, dramatically. The vision is that these AI agents can spot and fix issues way faster than traditional manual processes.
Yeah, that makes sense. Time saved on fixing bugs is time gained for building new things, right?
Absolutely. Speed is crucial. Another vital goal is cutting down on what's often called developer toil.
Toil, yeah, those repetitive tasks.
Exactly. The less exciting stuff that still eats up a lot of a developer's day. Automating bug fixes, automating code reviews. It lets skilled people focus on the harder, more creative problems.
Which is better for efficiency and probably better for morale too, I'd imagine.
Definitely. And then beyond just speed and freeing up developers, there's the quality aspect.
Right, enhancing the code quality itself.
Absolutely. By adding this automated layer of code review, the system aims to catch potential weaknesses early, making sure everyone's sticking to best practices and, crucially, checking that the fixes actually fix the problem they're supposed to.
So it's like having a super meticulous, always-on QA assistant built right in.
That's a good way to put it. A persistent guardian of the code base.
Okay.
And maybe one of the most forward-looking goals is the potential for a continuous learning loop.
Ooh, okay. What do you mean by that?
Well, as the system fixes bugs and reviews code successfully, it could potentially learn from those experiences. It might get better at its job over time, refining its own processes.
Huh. So the software gets smarter about maintaining itself with every task it completes. That's pretty cool.
That's a fascinating idea, yeah.
Now, you mentioned this system relies on AI agents. Can you break down how these specialized agents actually work together?
Sure. Think of them as like AI collaborators. Each one has a specific job in the whole software development lifecycle.
Okay.
And in this system we looked at, there are two main types working together: the AI developer agent and the AI code reviewer agent.
Got it. Developer and reviewer. Let's start with the AI developer agent. What's its main job?
Its primary task is pretty straightforward: automatically fix reported bugs in the software.
Okay, simple goal. But how does it actually do that? What are the steps?
Okay, so the process kicks off with something called issue triage.
Triage?
Yeah. The developer agent scans the project's GitHub repository. It's looking for open issues, bug reports, basically, that nobody's working on yet.
So it's finding the tasks that need attention, like a digital project manager finding work?
Kind of, yeah. It identifies an issue that fits the bill. Then comes problem analysis.
Okay.
Here, it uses an LLM. They mentioned Google's Gemini in the source,
Right.
to really understand the issue description. What's the problem?
Right.
And based on that understanding, the LLM figures out which specific files in the codebase are most likely involved.
That's crucial, right? Knowing where to even look in potentially huge code bases.
Exactly. Super important. Once it knows the where, it moves to code generation.
Ah, the fixing part.
Right. The agent grabs the content of those relevant files and feeds it back to the LLM. But this time, it asks the LLM to actually write the code changes needed to fix the bug.
Wow, okay, so it's not just suggesting, it's generating the actual code.
Yeah, and it formats this proposed fix as a standard diff patch. That's just a common way developers represent code changes.
Okay, so it has the fix written as code. What's next? How does it get into the system?
That leads to implementation and version control. This is pretty neat. The agent automatically creates a new branch in the Git repository standard practice.
Yep.
It applies that diff patch to the code on the new branch. Then it even generates a commit message automatically, using the LLM again to describe the fix. Then it commits the changes and pushes the new branch up to GitHub. It handles all those basic Git steps.
It's doing all the version control housekeeping that developers normally do.
Exactly right, all those essential steps. And the final step for the developer agent is pull request creation.
Okay, the PR, the request to merge the fix.
Precisely. It opens a pull request on GitHub to propose merging its fix from the new branch into the main code. And again, it uses the LLM to write a clear title and description for the PR.
And it links it back to the original bug report.
Yes. Crucially, it links the PR back to the GitHub issue it's supposed to solve. So you have that traceability.
Wow. So the AI developer agent basically takes a bug report all the way from discovery to a proposed coded solution ready for review completely automatically.
Pretty much, yeah. It's a very streamlined flow.
That is streamlined. Okay, now let's shift to the other agent, the AI code reviewer. What's its role in all this?
So once a pull request is opened, and this could be from the AI developer agent or a human developer.
Ah, okay. Either way.
Right. The AI code reviewer agent steps in. Its job is quality assurance, checking the proposed code changes. Think of it like an automated peer review.
Got it. Like a tireless colleague who just loves scrutinizing code. How does it work?
It starts with PR discovery. It finds open PRs that are ready for review and haven't been checked by the AI yet. It keeps track so it doesn't review the same thing twice.
Smart. Avoids redundant work. Makes sense.
Then it does context gathering. It pulls down the actual code, changes the diff from the PR.
Okay.
And it also looks at the PR description for links to any GitHub issues. This gives it the why behind the changes.
So it gets the technical what and the contextual why. What then?
Then comes the core part. LLM-powered review. The agent bundles up the code diff and that issue context and sends it off to the LLM.
Okay.
And it tells the LLM, essentially, act like an expert code reviewer.
Ah, okay.
So the LLM examines the changes really carefully. Is it correct? Does it follow best practices? Could it introduce new bugs? Any security risks?
Wow. Comprehensive.
Yeah, and does it actually fix the original problem? It's doing a deep analysis, much like a skilled human reviewer would aim to do.
That's a really detailed check. What happens after the LLM review?
Based on that evaluation, the agent does labeling. It adds a label to the PR on GitHub, like I reviewed or maybe I approved.
Just to show its status. Useful for workflow.
Exactly. Helps track things. And the final step is feedback or approval.
Okay. The verdict.
Right. If the LLM found problems, maybe potential bugs or style issues, the agent posts comments directly on the PR.
Specific feedback.
Yeah, pointing to the exact line numbers in the code diff where the issues are. It gives specific actionable feedback within a formal PR review on GitHub.
So constructive criticism generated by AI tied right to the code.
Precisely. But if the LLM analysis finds everything looks good,
thumbs up.
Basically, yeah.
Yeah.
If it thinks the fix is sound, the code is good quality, and it solves the issue, the agent can automatically approve the pull request.
It just approves it.
It can, yeah. Signaling it's ready to be merged.
So theoretically, a bug could go from report to fixed, reviewed, and approved, potentially without any human developer touching it beyond writing the initial report.
In some cases, yes. That's the level of end-to-end automation we're talking about. It's pretty remarkable.
It really is. Okay, let's dig a bit into the tech that makes this possible. We've mentioned large language models, LLMs, a few times.
Right. They're sort of the brains of the operation.
Can you expand on why they're so vital here?
Absolutely. LLMs, like Google's Gemini mentioned in the source, are key because they have that natural language understanding. They can read and make sense of bug reports written by humans.
Which can be kind of vague sometimes.
Exactly. They can interpret that nuance. Then they can generate relevant code fixes, analyze code diffs for quality and potential errors.
And even write commit messages.
Yeah, and PR descriptions that are actually readable and make sense. They're not just spitting out code. They're understanding the intent and communicating about the changes.
Bridging that gap between human language and code language.
Precisely. Now, managing these multi-step workflows the agents follow. That requires another tool. The system uses something called LangGraph.
LangGraph. Okay, what does that do?
LangGraph is basically a library for building these stateful multi-actor applications with LLMs. Think of it like creating a flowchart for the AI agent's tasks.
Ah, okay.
You define the steps, get the issue, analyze it, generate code, create PR as nodes in a graph, and you define the logic for how the agent moves between these steps.
So it orchestrates the whole process, makes sure the agent does things in the right order.
Exactly. It provides that structure for complex, multi-step AI processes, like a conductor for the AI orchestra, as you said before.
Gotcha. And the last piece you mentioned was the GitHub API. Why is that essential?
Well, the GitHub API is the bridge. It's the communication channel that lets these AI agents actually interact with the real world of software development on GitHub.
Right. They need to be able to talk to GitHub.
Yeah. They use it specifically via a Python library called PyGitHub to do things like scan for issues, create branches, push code, open PRs, post comments.
All the actions a human developer would do through the GitHub interface or command line.
Exactly. The API lets the AI agents become active participants within that existing developer ecosystem. Without it, they'd just be processing information in a vacuum.
Okay, so LLMs for intelligence, LangGraph for orchestration, and the GitHub API for interaction. Makes sense.
Precisely. Now, while this automated fixing and reviewing is already, pretty advanced,
But there's more.
well, the people behind this are looking ahead. They're thinking about even more proactive stuff. One interesting idea is a future QA agent.
Ooh, QA agent. Quality assurance. That sounds like a logical next step. What would that entail?
So the current system mostly reacts, right? It reacts to bug reports. It reacts to PRs needing review.
Right.
A future QA agent would be proactive. His job would be to constantly scan the entire code base, not just recent changes.
Like a tireless digital inspector just roaming the code.
Exactly, looking for trouble before it happens. And it would use an LLM to spot potential bugs, maybe recurring bad patterns.
Anti-patterns.
Yeah, anti-patterns, areas that don't follow best practices, maybe code that could be improved based on certain rules or standards.
So instead of waiting for someone to find and report a bug, it actively hunts for potential problems itself.
That's the core idea. And if this QA agent finds something...
What, then? Does it try to fix it too?
Not necessarily in this concept. Instead, it would automatically generate a new, detailed GitHub issue.
Ah, so it flags the problem.
Exactly. It creates a clear bug report outlining what it found and why it might be a problem, providing context for the developer agent or human developers to then pick up.
So it becomes part of the input for the developer agent. It's basically creating its own work or work for the team.
Yes. And that creates this really powerful closed-loop system. Issues aren't just fixed when reported, they're also automatically discovered and reported, potentially before they cause any real harm.
Bringing us closer to the idea of truly self-healing software.
That's the direction, yeah. Continuous improvement driven by AI.
That's a significant step. Okay, so pulling all of this together, thinking about the big picture, what are the main takeaways here?
Well, I think the biggest one is just the sheer potential you see when you combine LLMs with these agent frameworks like LangGraph.
Right.
We're seeing a clear example of AI moving beyond just, suggesting code snippets or answering questions. It's actively participating in core development workflows.
Bug fixing, code review, fundamental stuff.
Exactly. That feels like a pretty fundamental shift in how we might approach software maintenance down the line.
And what are the sort of practical implications? What does this mean for development teams?
Well, the potential is there to seriously boost developer productivity, right, by taking away some of that repetitive work.
Freeing them up for harder problems.
Exactly. More complex, creative work.
Yeah.
It could also speed up the whole maintenance cycle, getting fixes and improvements out faster, making software more secure more quickly.
So faster cycles, maybe more engaged developers.
That's the hope, the expectation. And ultimately, this should contribute to building software that's just more robust, more reliable, higher quality overall, thanks to automated checks and faster fixes.
But it's important to stress this isn't about replacing human developers entirely, is it?
Oh, absolutely not. That's a crucial point. Human expertise, judgment, oversight, they remain essential. Developers are still needed for the really complex, novel problems, for making big architectural decisions, for setting the overall direction. Think of these AI agents as powerful assistants, augmenting human skills, not replacing them.
Powerful tools in the toolbox.
Exactly.
So, to kind of wrap it up, the main aha moment here is seeing AI move from just generating stuff to actively doing stuff, participating in the real work of keeping software healthy and improving its quality.
Precisely. It's a potentially transformative development playing out right now.
And for everyone listening, we hope this deep dive has given you a clearer picture of this shift in software development. It's a shortcut, maybe, to understanding some pretty cutting-edge advancements.
Indeed. And it leaves us with a really interesting thought, doesn't it? As AI takes on more of these routine development chores,
Yeah.
what new higher-level challenges will human developers get to focus on? What becomes possible when a lot of that toil we talked about is automated away?
That's a great question to ponder. What's next for human ingenuity in software?
Exactly. Something to think about how this kind of AI automation might ripple out and apply in other fields you're interested in, too. Thanks for joining us on this deep dive.